First we make a copy of the data frame where we can save computed values. Dataframe.copy will help us with that. For the next part, let's consider this. Suppose we want daily returns for date at index t. Then we need to divide the value at index t by the value at index t-1 and subtract 1. We want to do that for all the dates, starting with index 1. Now let's code this. Here, df1 : picks all the rows from 1 till the end, and df : -1 picks all the rows from 0 till 1 less than the end. This operation cannot be done at index 0 since we do not have the price of the stock prior to this day. So we set the values at the 0th row to all zeros. Finally, we return this data frame. You must be wondering, why did we use .values attribute of one of the intermediate data frames? The reason is to access the underlying NumPy array. This is necessary because when given two data frames, Pandas will try to match each row based on index when performing element-wise arithmetic operations. So all our effort in shifting the values by 1 will be lost if we do not use .values attribute. Okay, now let's run this. Here is what the daily returns look like compared to the original stock prices. As you can see, the original prices of SPY and Exxon are quite different. However, since the daily returns are implicitly normalized, they show up at a comparable scale. Each daily return value is either positive or negative fraction relative to the previous day's value. This reveals that Exxon or ExxonMobil actually matches ups and downs of the SPY quite closely. There is another way to compute daily returns, this time directly using Pandas data frame. Here is how we can do it using Pandas data frame function shift. Note that we still have to replace the values at the 0th row with zeros. The reason for doing this is Pandas leaves these unknown values as nan by default. Now let's check the output. As you can see, the result is same as before.